Hey everyone, I'm Nick Raboy from MongoDB, and in this tutorial we're going to see how to build a serverless function using AWS Lambda that communicates with MongoDB, in particular MongoDB Atlas. And we're going to be doing this with Java, so the Java programming language and the Java driver for MongoDB. Now if you've been keeping up, you'll notice that I do have a tutorial out that does the same thing but with Kotlin. However, this particular tutorial is going to focus on the Java side of things. But if you're a Kotlin developer, do a quick search on YouTube or on the MongoDB Developer Center for Kotlin, and it should pop up. Some prerequisites regarding this tutorial. You will need to have a MongoDB Atlas account. We're going to be using the free tier cluster for this particular tutorial, so you don't need to pay anything. You will, however, need to have set up network rules in your cluster. So that way you can communicate with AWS Lambda. You're going to need to have a user created with correct user permissions. All of this you should do prior to watching this tutorial because it is out of scope for this particular tutorial. We're going to focus strictly on the development side of things. If you need help doing that, there are other tutorials on YouTube and on the MongoDB Developer Center website that will walk you through this process. It shouldn't take more than a second, but just know that it is out of scope for this particular tutorial. Now in this particular example, I will be using IntelliJ as my IDE. It is not a requirement to be successful with this tutorial, although if you feel more comfortable following along with me, I do suggest that you give it a shot. Otherwise, you can use the command line or whatever other tool that you wish to use. Now up on my screen, you'll notice that I do have IntelliJ open. I'm going to create a new project. This new project, what I'm going to do is I'm going to call it maybe My Lambda Example, and I'm going to save it to the desktop. This will be a Java project. I will be using Gradle. You can use Maven if you prefer. And I will be using the groovy Gradle DSL. Feel free to use Kotlin if that's what your preference is. But this is the setup that I'm going to be using. And I'm going to say create. Now once that's done, you'll notice that I do have my build.gradle file open. We do need to add a few dependencies here to be successful. For example, we need to add the AWS Lambda dependency for Java. We need to add the MongoDB driver dependency for Java. And we're going to do some slight configuration so that way we can build a fat jar to be uploaded to AWS Lambda. So starting with the AWS Lambda dependencies, what I'm going to do is I'm going to paste them in. These dependencies can be pulled from the AWS Lambda website. Your versions may vary depending on when you're watching this particular video, so just make sure you note any kind of differences that might have come up over the years. So this is strictly AWS Lambda. What we also need to do is we also need to import the dependencies from MongoDB. So what I'm going to do is I'm going to paste this in. Likewise, I am using a particular version in this tutorial. If the versions change in the future, go ahead and make the correct adjustments. Before we go any further, what I'm going to do is I'm going to click on this little icon to refresh our dependencies so that way they download into our project. And when they're done, we're going to do one more thing. We're going to add a library or plugin that will allow us to build a fat jar, like I said, because when we upload this jar file to AWS Lambda, we want to make sure that all of our dependencies are included. And to do that, we will need to take care of a few things. So there are a few different ways to create a fat jar. What I'm going to be doing is I'm going to be using the shadow jar plugin. It's just one of many different ways to get the job done. But I'm going to paste that into the plugin section. Just note that the version may be different from when you're working on it. But this is the shadow jar plugin. Now, to be successful with this particular plugin, we do need to add an extra step. This extra step will allow us to define our main class, which we haven't created yet, but we're going to set the foundation for when the time comes. So let's go ahead and change the jar task. So what I'm going to say is tasks.jar, and I'm going to say manifest.attributes. I'm going to say main class, and I'm going to say equals. And in our particular circumstance, it's going to be example as the package name and handler as the class. So just make note of these two items. You don't have to name it the same thing that I did, but please make sure that you're consistent throughout. If you choose to use a different class or a different package, make sure you reflect them in this build.gradle file. You will need them as well when it comes to the AWS Lambda portion of things, so make sure that you do keep that in mind. I'm going to refresh my dependencies one more time after I save. And now what I can do is I can proceed to creating that package and that class. So I'm going to right click on Java for the main, and I'm going to say new, and I'm going to say package. This package is called example. And inside the example package, what I'm going to do is I'm going to create a new Java class, and I'm going to call this handler. To start things off, I'm going to paste in some AWS Lambda boilerplate code. This is just some code that you can find on the AWS website, but it's going to be a starting point for us to talk about and progress throughout this tutorial. You'll notice for my handler class definition that it implements the request handler. The request handler is going to accept a user input of map, so a string key and a string value. And for now, it's also going to return nothing, so return void. Let's go ahead and import this dependency, so that way it adds us to the dependency list. Inside of the class itself, we have a handle request function. For now, it's going to be returning void, and it's going to accept a map of user input and a context. We're going to be changing the response type as we progress because we're not going to want to return void. We're going to want to return data that comes out of MongoDB. So these errors will go away. It'll look a lot better. It'll be a lot more useful. But this is a boilerplate starting point when it comes to this particular application. So the first thing that we want to do inside of this function is we want to define our MongoDB client. So this client is going to connect to our cluster. And at that point, we're going to be able to do operations. So to make this successful, let's go ahead and add the following. So we're going to add private final, and we're going to call it Mongo client, and then we're going to say Mongo client. Let's go ahead and import things as we progress throughout this example. So we're going to import the class. Mongo client's not set to anything yet, so it's not doing anything. It's just a variable. Let's go ahead and create a handler constructor method. So we're going to say public handler, and inside of this handler constructor, what we want to do is we want to define what this Mongo client is going to connect to. So we're going to say Mongo client equals Mongo clients plural, and we're going to say create. Now inside of this create method, what we're going to be doing is we're going to be defining the connection string. So the connection string, I'll show you in just a moment after we import this dependency. So I'm going to say import that dependency. And let's go ahead and look to see what that connection string looks like. So inside of the web browser, I do have the MongoDB Atlas dashboard. I do have an instance created. If I click on connect, and then I click on drivers, and I navigate to the driver that I plan on using, which is the Java driver and the version, this is the connection string that we want. And you'll notice that this connection string does have a username and a password. You'll be wanting to swap these values out with the username and password that you defined when you set up your user within MongoDB. So these are not actual values, these are placeholder values. But knowing that we know this connection string right now, if we go back into our code, we could paste it in as a string right here on line 15. We should not do that though. Because if you add it as a string directly within your source code, you're potentially going to end up by accident committing your username and password to your version control system, which probably isn't a good idea. So best practice would be to use a configuration file, or for the purpose of AWS Lambda, an environment variable, because Lambda does offer the opportunity to add environment variables to each of your functions, and you can even use secure environment variables as well. So we're going to go with the environment variable approach just for good practice reasons. So what I'm going to say is system.getEnv, and I'm going to call this environment variable MongoDB Atlas URI. You can call it whatever you want, but just remember it when it comes to the time for AWS Lambda and configuration. So I have my MongoDB client created. Now what we can do is we can get a reference to our database and collection that we wish to use. So for this example, let me explain what we're going to use. So for this example, if we go back to MongoDB Atlas, what we can say is if for any of your instances, you can click on this ellipsis menu and you can say load sample dataset. For this particular tutorial, I'm going to be using one of the sample datasets. The sample dataset in particular is going to be called sample mflix. That's the name of the database. And I'm going to be using in particular the movies collection. So if you've never used this dataset before, this is more in line with what you would see on the Internet Movie Database, so IMDb, and it just gives information about movies, so the title, the plot, the genre, the year, things like that. You don't have to use this sample data set if you don't want to. You could use your own data, but if you want to be consistent with what I'm doing in this example, you might want to follow along. So inside of the handle request function, let's go ahead and establish getting that particular reference to the database and collection. So what I can say is Mongo database, I'm going to say database equals Mongo client.get database, and I'm going to provide the database name. And this is going to be sample mflix. Let's go ahead and import this Mongo database and move on to getting our collection. So I'm going to say Mongo collection equals database.get collection. And I'm going to be using the movies collection. And let's go ahead and import this. All right, so we have references to each. Now we get to do the exciting stuff. Now we actually get to run our queries. So your functions, they don't have to be just query-based. You could insert data, you could do updates, you could do other operations, aggregation pipelines, things like that. For the sake of this example, I'm going to only do a query. So I'm going to read data from MongoDB. So as far as CRUD goes, this is the R, so the retrieve or the read operation. But before we do that, let's go ahead and change our data type here. So right now we're saying void. We're returning void. We're not returning anything. Let's go ahead and change that a bit. Let's go ahead and change that to list document. And let's go ahead and import the document. For this particular example, we're not going to be using any POJOs. We're not going to be doing any class mappings to MongoDB BSON documents. We're going to use raw documents. But I encourage you to look through the documentation to see how to do all of that because it's very exciting stuff. So we changed the return type to list document. We need to change it here as well. We're going to say list document. And likewise, return null. That's fine as well for now, but it will change to an actual response. So now we're going to be expecting to return a list of documents, which the end user will see as just an array of objects. So let's start adding some code here. Let's go ahead and say BSON filter equals new BSON document. So we're going to create a new filter. So this is how we're going to query for MongoDB documents. Let's go ahead and do our import operation here. Let's go to import each. So this filter is blank. So that means that if we apply it on any of our collections for our find operation, it's going to find all documents in that collection because we're not filtering on anything, it's blank. And more on that in just a second. Let's go ahead and say what we want our return type to be. So we're going to say list, we're going to say document, we're going to say maybe results or response or whatever you want to call it, equals new array list. And this is going to be of type document. And let's go ahead and import that array list. So we have results. We can even change this line 34 to reflect, so results. It's empty though. We have no response coming back yet because we didn't actually do the find operation. So let's go ahead and do the find operation. Let's go ahead and say collection.find. Let's pass in that filter from line 30. And if you've ever worked with the movies collection for the sample data set, you'll know that there are thousands of movies to be returned. We don't necessarily want to return thousands of movies because it's a network heavy type of operation. There's a lot of data coming back. So for this example, let's go ahead and limit it. So we're going to say limit to 5. There will be a maximum of 5 movies coming back. Let's go ahead and say that we want the result set to go into our results variable. So now we are moving our results into the list of document. If you don't want to move all of your results into a list of document or a list of whatever data type that you're working with, you could use a cursor. Cursors are out of scope for this particular tutorial, but that's a different way to handle your data if you didn't want to work with, say, for example, limits or loading all of your data at once. But we have results. Results should have data, provided, of course, that this movies collection has data, which it does. So I'm going to save it. Let's go ahead and try to build this application. So I'm going to open up my Run Anything menu within IntelliJ. You can use the command line. You can use whatever you want. I'm going to say Gradle, and I'm going to say Shadow Jar because we're using the Shadow Jar plugin. It's going to take a second to build, and it looks like the build was successful. So looking at the project in my Finder window, I can look for that jar file. It's inside the build directory. It's inside the libs directory. And this is my fat jar. This is what I'm uploading up to AWS Lambda. I could zip it if it's large or if I've got other stuff going on, but this should be fine for the sake of this particular example. So let's go into the AWS Lambda portal. I'm going to say create function. What I'm going to do is I'm going to give it a name. I'm going to say my Lambda function. Doesn't really matter what you call it. Do whatever makes sense to you. but the naming is not really related to the actual project here in this example. I'm going to change the runtime to Java 11 or whatever Java you want to use. And I'm going to create that function. Once the function has been created, there's a few things that we have to do before we try to run it. The first thing that we want to do is we want to upload the jar file that we just created. So what I'm going to do is I'm going to look for it on my local computer. Once you find it, go ahead and click Save. Once the jar uploads, you will need to do another modification. So if I scroll down into the runtime settings, we do need to make adjustments to this handler. So I'm going to click Edit. So as you saw inside of our shadow jar code inside of the build.gradle file, we defined an example package and a handler class. Just like in our actual Java project, we defined an example package and a handler class. So this example represents the package in this case, which you may have called it something else. Hello represents the class, which we're not using hello in this example, we're using handler. And then handle request is our function. So I'm going to click Save. You're going to want to change that data with whatever makes the most sense for your project in case you didn't follow along exactly to what I did. So that's part 2. There's a third step here now. So what we want to do is we want to go to the configuration tab within AWS Lambda, and we want to edit the environment variables. So let's go ahead and click Edit. We're going to add an environment variable. What we called it inside of our project, we called it MongoDB Atlas URI. And for the value, if we go back into our MongoDB dashboard here, we're going to click Connect. We're going to go to Drivers, and we're going to copy over this connection string. Don't forget to change the username and password to whatever you had set in your own account. All right, so after you've added your environment variable, you should be good to go at this point in time. We can go to the Test tab. You don't have to give it a name. You don't have to worry about the event JSON. That just represents the input. We're going to get to that in a moment. But what you can do is just click Test. When it's done, you can validate that everything worked correctly. So I do have some movies coming back. I have no idea what this movie is, but it looks to be accurate to what was in that movies collection. And there should be a maximum of 5. Now, there's a lot of data that came back because each one of those documents does contain a lot of data. We did no projection in our query, so it's getting every single field, but it does look accurate for what we tried to do. Let's go back into our code. We can do better. We can modify this to make it a little bit more exciting. Let's go ahead and modify it so that way we do actually have a filter that is not blank. So let's go ahead and add some logic up here. Maybe we add some logic after we create the filter. So in this case, if the user provides a title of a movie, let's go ahead and use it as part of our query. So that way we can narrow down our result set. But if they decide not to use a title, let's go ahead and get everything. So we want to give the user some options here. Your actual logic might vary. So what we can do is if event dot contains key, so we're looking for the title key in our map, because if we look at line 25, we're expecting a map where we have a string key and a string value. So we're looking for the title. If it has that key, and we're looking for if event dot get title dot is empty. So we're saying if title is not empty, hence the little exclamation point here. So we want to make sure that it has a key and that it actually has a value in it. So if that's true, we're going to say filter equals filters.eq title, and we want to say event.get title. So we're going to get the value from that key. Let's go ahead and add this to our imports. So that should be good. So if the title exists, let's go ahead and use it. So I'm going to save it. We're still going to limit it to 5 just in case we end up with a movie like the Jason Voorhees movies that have like 12 different movies. We're going to limit it to 5, but let's go ahead and save it. We're going to open up our Run Anything menu, and we're going to say Gradle Shadow Jar. Once it's done, let's go ahead and go back into our Lambda dashboard. Let's go ahead and go to the code area. We're going to say Upload. We're going to upload that jar again. I'm going to save it. We don't need to edit the environment variable. We don't need to edit the handler. That's already still there. Let's go back to the Test tab. Let's go ahead and first validate that we didn't break anything, so I'm going to leave it as is for now. We can check to make sure that we have data. Looks like we still have data. So let's make an adjustment here. So this is our event JSON. It has a bunch of stuff. It doesn't hurt us if we add extra stuff because we're only ever looking for title. But let's go ahead and say title, and we're going to say Batman for a Batman movie. Let's go ahead and run it now. So test. It ran a lot faster because it only found one document here by the exact title of Batman. But Gotham City looks good. That has Batman written all over it. So it looks like it worked. So I just want to reiterate some of the stuff that we saw in this particular tutorial. Once again, this is a Java-oriented tutorial. It's for working with AWS Lambda and MongoDB. We used the Java driver for MongoDB. If we look at our code here, we didn't do a whole lot, but it does set the foundation in case you want to do larger AWS Lambda projects with MongoDB. But we created our MongoDB client. We got a reference to our database and our collection. We created a filter, and we did a basic find operation. Now, you have to know that there are other operations in MongoDB to do much more exciting things, but this is just an example to get you started and in the right direction. Big thing to note when it comes to AWS Lambda and maybe Java in general is make sure that you create a fat jar. Otherwise, you're going to end up with different kind of class errors or dependencies missing when it comes to running your Lambda function. And there are other ways to do it. You don't have to use a shadow jar, but it is an option. If you like this tutorial, make sure you give it a thumbs up on YouTube, subscribe to the YouTube channel, and even drop us a comment. If you got stuck anywhere, I do look at the comments. I can help you out. If you're looking more for the Kotlin side of things with Lambda, I do have a tutorial. Like I said, I created a video for one. I created a written post for one. This particular Java video has a written version of it as well. So just head on over to the Developer Center for MongoDB. That's developer.mongodb.com. And you can find that there in case you want to read along and follow it in a different direction. Until next time, everyone, have a great rest of your day.